In the previous video, we discussed how to select components from the existing library in EasyEDA. And in worst case scenario, even if you can't find the symbol within the library, there are hundreds of symbols contributed by users. But it's really not a safe bet to use others' work without any verification. So instead, in this video, we'll see how we can build custom symbols not only by using manual methods, but also by exploring how to use shortcuts like the symbol wizard and datasheet extraction to make the entire process super fast. There are three ways to create symbol within EasyEDA: manual, symbol wizard, and finally datasheet extraction. First, we'll start with the manual method to better understand all the tools and workflow for creating a symbol, and then move on to the other methods to reduce the time and the effort required. To start, go to Files, New, and click on Symbol, which should create a new symbol sheet. Here, the tools are very similar to the ones that we are used to in the schematic editor's drawing tools, except for the additional pin tool for adding the pins to the components. Using these tools, we can build any type of symbols we need, including ICs, transformers, and resistors. But to keep things simple, let's start with replicating the IP5306 IC. Since we are going to build an IC, let's start with drawing a rectangle using the rectangular tool. Next, let's add the pins using the pin tool. Currently the pin says 3, but usually the IC numbering starts with 1. So to change this value, we need to go to the object panel on the right and change the name and the pin number as per the datasheet. For spice property, we don't have to worry much since it's used in simulation and we are not going to do any of those. As for the next two settings, set them to S to display both the name and the number of the pin, so it's visible in the schematic sheet. The pin length will determine the size of the pin. For now, let's keep this at a default 20. And here in the pin placement, if you prefer accuracy over simplicity, you can simply use the X and Y coordinates to directly change the position of the pin instead of dragging around it with a cursor. The next few options are for personalization, where we can change the pin color, the text color, but again, I prefer the default settings of the EasyEDA. Then the next few options can help in setting the electrical properties of the pins, like mentioning the inverted signal pin with a dot property or mentioning the clock signal of the IC. In our case, IP5306 won't need both of these options. There are some situations where we would like to have the pins but not use them. In such case, we can use this property to hide and unhide the pins. Currently, it doesn't seem to do much, but the effect will be on the schematic editor when we import this symbol. So just for a demo, I'll keep this at no and later we'll come back to change this value. Then we have the electrical properties, which will help in defining the electrical properties of the pin. In this case, we'll set the V-in pin to power input, as this pin carries the power that goes into the IC to charge the battery and also power the IC according to the datasheet. Finally, there are a few more options, but they are purely for aesthetics, so I'll leave them at default. And this completes the setup for the first pin. Now, to add the second pin, we can follow the same process. To make entering values and the pin number a tiny bit easier, we can just double click on a value and change it directly. However, we still have to use the properties panel for more options. Anyway, I think this should give you an overall idea on how to create pins for your symbol in EasyEDA. So I'll quickly add few more pins and modify them as required. This symbol looks good, so let's save it by using the shortcut Ctrl S and giving it a name. Let's call it IP5306 manual. You can also provide other information like supplier details, supplier part number, manufacturer details, link to the datasheet, and more. But for the sake of simplicity, I'll stick with the name and the description. Once that's done, hit save. Since the symbol was created within this project, we would instinctively expect it to be under this folder. But by default, this symbol will be stored in a global workspace, which can be accessed in all your projects. Now to check if it's actually located in the global library, go to the library and make sure the search engine type is set to EasyEDA and the class is set to workspace. Here we can see the symbol we created with the name IP5306 manual. Let's import this into the schematic and see how it looks. The first pin is missing. Oh yeah, that's because we set the pin show property to no. I'll quickly go back to the symbol editor and fix the property to S and save the file. The symbol is not updated yet. So to reflect the updated symbol, we need to right click and select the option Update from Library. This should update the symbol to the latest version. I know you would have noticed this by now. This custom symbol is not as visually appealing as the ones we got from the LCSC library. But of course, we can put more effort into making the symbol manually, so it looks very similar to the one from the supplier. But there is an easier way to do it. So let's start with creating another symbol. Here, instead of drawing the symbol from scratch, click on the symbol wizard icon on the toolbar, which should give us a pop-up wizard to create a custom symbol just by entering the pin configuration we need. By default, it's set to 12 pins, but we can change it to By default, it's set to 12 pins, but we can change it to a custom value by adding the pin name in order from the datasheet. When you click OK, it should auto-generate a symbol. This looks really good, but I'll just move these pins to the left so it looks exactly like the part from the pre-existing library. You can see this does a phenomenal job of creating a symbol, but we still need to manually adjust the pin properties or any other information that we like to change. But I hope you know how that process goes, so I'll quickly save the symbol and import it into a schematic. You can see this is very similar to the ones from the existing library, and we need to have the ground pen colored differently for easier understanding. And did you notice this was way faster than the previous method? How about I show you an even faster and more efficient way of creating a symbol? Let's start with creating a new symbol. Here, let's ignore both the manual method and the wizard technique. Instead, click on the datasheet extraction icon on the top menu bar. This should bring up a pop-up that will generate a symbol just from the datasheet image, which is super cool when you consider manually building a 50-pin IC. This pop-up is pretty simple to use. Just select the type of IC you need and import the datasheet image. Here I'm just pasting a snippet I captured from the datasheet. That doesn't look right. You might face this issue if you use a color image or a low resolution image. But it's pretty easy to fix. Just paste a better quality image with clearer text, which will fix the issue and autofill the complete pinout names for the IC. Once we are sure about the pin names and numbers, click on Next Step. Here we can select the pin designator and name of the symbol and click on OK. You can see that this created the part much faster than the previous two methods without needing for any manual modification. But this method is not guaranteed to work with all the components or all the data sheets, although it works for most of the ICs. Now let's save the symbol and import it into our schematic. You can see we successfully created a symbol for EasyEDA with very little effort. But this symbol is just for representation and doesn't say much about how the physical component is placed on the PCB. That's why in our next video we'll discuss how to create a custom footprint which will define the shape and dimension of the physical part within EasyEDA. This brings us to the end of our video. If you have any questions or doubt, drop them in PCBcupid Q&A section, and don't forget to like and subscribe for more PCB related content. Until then, keep learning and keep creating.